Fill out the table using the functions and x values given. Then we're going to graph each function using a different color and answer questions 1 through 3 when you're done. So first, the graphing, or actually filling out the table. So this is the x value that we're being given, and I'm going to plug it into the x in the equation. So 2 times 0 is 0. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and 2 times 5 is 10. Okay, I'm going to do different colors now. For this one, when I plug in 0 to this x, zero to the second power is still 0. 1 to the second power is 1. And I'm going to be thinking about it like this, you guys. I'm just going to be like expanding it in my mind and then multiplying the number by itself twice. So then 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. And then for the last one, we have x in the exponents. This is probably our exponential function. So 2 to the 0 is 0. 2 to the 1 is 2. 2 to the 2 is 4. 4 to the 2 is 8. 2 to the 4 is 16. And then 2 to the 5 is 32. So now I'm going to graph my functions, and I'll start with my linear function, right? Linear. So we have 0, 0. Then we have 1, 2. Then we have 2, 4. Then we have 3, 6. And then we have 4, 8. And then we have 5, 10. Now I'm going to graph my quadratic. So we have 0, 0, 1, 1, 2, 4, 3, 9. Notice how for the odd numbers on the y-axis, you're going to have to go in between the numbers, right? Because 2, 4, 6, 8, it's counting by 2s. So 1 was between 0 and 2, and for 9, which I just did, is between 8 and 10. 4, 16. And 5, 25. 25 is between 24 and 26. So there's my quadratic equation. And then lastly, we have our exponential. So we have 0, 0. Everything starts at 0, 0. 1, 2. 2, 4. Same so far, it's increasing almost the same. 3, 8. 4, 16. 5, 32. All right, so there's our 3 functions. And now we're going to answer questions 1 through 3. I'm just going to kind of read them and talk about them aloud. Which function shows a constant rate of change in its y values? How is this displayed on your graph? Well, constant rate of change should tell you or indicate, oh, linear, right? And we see that this is going up by 2, up by 2, up by 2, up by 2, right? So in the table, it shows us in the y values that it's increasing by 2. And then in the graph, even though it's super terribly drawn, it should be a straight line because it's linear. Which function is largest between 1 and 2? How is this displayed on your graph? So between 1 and 2, for the linear, it goes from 2 to 4. And then from the y, it goes from 1 to 4. I'm sorry, for the quadratic, and from here it goes again from 2 to 4. So the largest increase would have been for the quadratic function because it jumped from 1 to 4 and the other ones jumped from 2 to 4. And 2 to 4 is a small jump and 1 to 4 is a bigger jump. So we should have said function, or we could have said the quadratic function or function 2, whatever you wanted to call it. Eventually, which type of function shows the most rapid rate of growth in its y values? How is this displayed on your graph? Eventually, we saw that everything kind of stayed the same up until 4. And then at 5, the linear was like the lowest, and then the quadratic, and then the exponential. So eventually, the exponential graph grew the most rapidly and will continue growing the most rapidly because it's going to continue multiplying by 2. If we looked at the quadratic's next number, it would be 6 squared, which is 36, right? So if we continued this one, 6 squared would be 36, right? That would be the next coordinate. And then for the exponential, it'd be 6, and then 2 to the 6 would be double 32, so 64, right? So 64 and 36. The exponential just is going to continue growing the most rapidly. And that's always true. Exponential growth is the most rapid growth. And that is how viruses spread, which is why viruses are so hard to contain and why we're currently in a pandemic and potentially in a lockdown, right? Or have been experiencing that.